Good morning, everyone. Today, we are going to talk about Ethics Challenge organized by ICRA 2022. My team includes Sachin, Zishan Islam, Shiksha Sabarwal, and Aditya Chebi. Next, please. All right. The problem statement for our ethics challenge is to propose an ethical policy framework for a social robot with an indoor environment that fetches objects from position A to position B based on human commands. So that is the main theme of our ethics challenge. And we are focusing on various parameters, including issues, principles. We talk about our approach, our assumptions, the scope of the problem, the basic principles, the operator class, the policy, and at the end, we also define the algorithm, as well as strengths and weaknesses. All right. So the design of our policy is based on values. So there are total 5 values that we take into account, which define our entire project. So the values are autonomy, safety, privacy, transparency, and inclusivity. In autonomy, we focus on the user. The user should always be in control of the robot's decisions. So the user should be having the command, the control to lead the robot's decisions. For safety, we have robot will always operate prioritizing the safety of humans. The robot at all times should take care of the safety of humans and shall not harm humans in any way. For privacy, we have data is collected only through informed consent. So we make sure to include the privacy factor in our policy in order to not collect data without any consent and only after asking for permission from the user or the owner of the robot. For transparency, we talk about the ethics policy and the decisions made from it will always be made accessible to the user. So the data and the policy and the decisions should always be accessible to the user or the owner of the robot. And there shall be no hidden secrets or anything like that. For inclusivity, we have policy may be adapted to each country or religion or region. So basically in inclusivity, we mean that our policy is inclusive or flexible with any country's values and policies. So that's about it. Now over to you, Sachin. Thank you.
So when we were thinking about the robot fetching items around the house, we thought, okay, first of all, who's going to be using the robot? It's not always the owner. It might be the owner's kids. It might be a person who's maybe disabled that might need a little bit more help. It might be a neighbor. It might even be like a first responder. So we thought all these different people should not have access to the same items, right? The same way like an underage child should not be able to ask for alcohol or maybe financial documents like credit cards and all that. So what we decided is depending on the person who's using the robot as well as the item that's being fetched, we'd have specific rules. Now these rules, most of it would be set by the company. For example, there are some things that are just infeasible for the robot to fetch, like the robot cannot go fetch a table, right? And similarly, there will be some things that are easy for the robot to fetch, like for example, credit cards, but then we want to limit their usage, right? So in these cases, we make these rules customizable to the user to a certain extent so that the user has autonomy of the robot's decision-making process. Now, for our decision-making algorithm, we follow 3 steps. Okay, the first step is result-focused verification. So here, the robot thinks about, okay, who's making the request and what item are they requesting for, right? And depending on this, it makes a couple checks. First of all, does a person even have access to the item? Second, is a person in a proper mental condition to be able to ask for that item? And third, are there any privacy settings? For example, has a person requested for data collection to be turned off? If so, then stop recording data. So these kinds of checks are performed first. Then the robot goes on to execute its task in section 2, right? And here it makes sure to keep the safety of the human and the robot itself and the environment as a priority as it executes a task, and to verify the truth of the instructions. For example, if the person goes and asks for a spoon, then the robot should not go fetch a knife, right? So it should make sure that the correct object is being fetched. And finally, after the task is executed, we have the post-processing. For example, if a fire extinguisher or any other kind of emergency item is requested, then we allow the robot to ask the human whether they need to call emergency services, right? And if the item is dangerous to human, for example, if it's a really hot plate or if the robot is delivering a knife, then the robot makes a notification that, hey, this is a dangerous item, right? And the robot also sits and waits for 10 seconds to see if there's any feedback. For example, if it has made an incorrect ethical decision, then it can listen to the human for feedback before it stores that information or maybe communicates that information to the company so that we can make better decisions in the future. And the reason for our approach is basically we thought of a couple of questions, right? First of all, what are the most important values to the consumer? And what's being currently talked about, what's currently in contention right now? For example, privacy is a big matter. Then we also talk about what are their concerns and what will the average user want the robot to do and what kind of items will they want to fetch and so on, right? And finally, we thought about how the company can achieve a fair balance between ethical decision making as well as product performance. One should not overtake the other.
Hello everyone, myself Zishan, and I will be explaining the strengths and weaknesses of the approach that we have discussed. And thanks to Sachin and Shiksha for the prior introduction. So as you know that I'll be first discussing the strength section. So as you know that, and we have seen in our algorithm section that we don't have any learning approach or any learning module in our algorithm. Hence, very well-defined and replicable approaches are there for any particular command to be executed. So these kind of transparent and replicable methods and policies give actually a boost to the consumer confidence that what the robot is going to perform is something that is going to be safe. Now, one of the the second point is that the ethical policies that we have, the value-centric design that we have used, is having inclusivity as one of its ethical policies. Hence, in order to address that particular ethical policy, we are having flexibilities with regards to different demographics that our robot is going to serve to. And there can be differences in like values and principles to a certain extent in the different demographics. Hence, in order to address that, a certain amount of flexibility will be given to the customers to customize what can be banned and what cannot be banned in certain different areas. So coming to the weakness section, and this is like the weaknesses that we have observed are mostly very fundamental ethical questions that have plagued humanity since ever. So for example, choice and safety are freedom of choice and safety are two fundamental values that are always against each other. They are like kind of trade-offs. So giving more of one will reduce the other. So it is like a zero-sum game. So we have to decide what amount of freedom should be given to the user in order to guarantee its safety. There are certain gray areas in ethical concerns where harm has to be quantified. I mean, the situation is something like it has to do a greater harm or a lesser harm. Our robot has to be taught how it can measure or quantify varying degrees of harm and perform in the most optimized way in those situations. And these particular policies have not been designed with all the stakeholders in the room at the same time. So that is it. Next. So that is it from our side, guys. Thank you very much for listening to us. Thank you.